let's discuss about different types of electric motors in robotics. So we have DC motors, AC motors and special motors. So DC motors, what are the DC motors? DC motor is a rotary electrical motor that converts direct current, that is DC, direct current electrical energy into mechanical energy. Nearly all types of DC motors have some internal mechanism, either electromechanical or electronic, to periodically change the direction of current in part of motors. DC motors widely used as they could be powered from existing direct current lighting power distribution systems. DC motor speed can be controlled over a wide range using either variable supply voltage or by changing the strength of the current in its field windings. Small DC motors may be used in toys or some tools or appliances or even for competitions. So you can see in this picture it is used for a lathe machine, fans and cloth mending because it is having constant speed. So that is the reason. And apart from that, larger DC motors are currently used in propulsion. Propulsion means it will indicate to and fro motion of electrical vehicles, and elevator and host means which lifts weight. So in this animation you can see how the rotor winding is rotating. So at the end you can see the torque, one is upward and one is downward. That is based on Fleming's left hand rule. So in this manner you can understand how the rotor, these dark color, black color ones are taken as the so now you can see two types of motors indicated here, DC motor, and then the windings are shown here. This is the construction part, how the motor is done. This is the starter and the frame of it, winding poles inserted there. These are the windings externally present, and then this is where the DC current will be formed. And now accordingly you can see the connectors here, DC winding connectors. So how the EMF is produced, if you charge it, the EMF will be produced, which will make the rotor. These are the commutators which are taken as a fragment. It have the slots here. In the slots only winding will be done. This is the commutator. Commutator means it helps in rotation, and then the shaft is taken in the center. The middle one will be, once you give the battery source, the carbon will be, this is called as brush, the black part. So the torque is produced here once the EMF is generated. So it makes the, we are taking only one winding and showing here. So the current generates following the left hand rule, Fleming's left hand rule. See how the winding is done. This is only for one winding. As such, many windings will be done. So you can see the force, how the motor is made to rotate. So this is about motor. And now let's see the next classification, DC series motor. DC series motor, it will have the winding in the series form. That is, series motor will be connected with armature and the field winding in series with common DC power source. So the motor speed varies as a non-linear function of load torque and armature current. And current is common to both the starter and rotor, yielding current squared behavior. So here you can see this part is indicating the shunt winding, and in the first diagram that was the. So now let's discuss about series motors. DC series motors, the windings will be connected with armature and the field windings in series common with the DC power source. The motor speeds can be varied on non-linear function of load torque and armature current in both the starter and the rotor windings. Current is squared behavior. Okay, a series motor has very high speed torque and it can't be used without load. In this picture it depicts how the parallel shunt connection is done from the armature. Here it is the series connection here. It goes one to the other. Now compound motors are the ones which will be combined form. Both shunt and series will be used. Mainly used for rolling machines and stamping machines here, The yellow one is the stamping machine. Here the sheet is rolled. So Next, let's go for permanent magnet, DC permanent magnetic motors. So in the DC permanent magnetic motors, we have brushed motors as well as brushless motors. Magnet will be fixed here, no windings will be present. With the help of magnet only, it will be used. The motor starts rotating because magnets generate EMF, right? It will be mainly used in toy cars and all. So you can see this picture depicts brushless DC motors. So in this way only magnets are used here, and this one is brushless DC motor. You can't see any brushes here. Rotor is there at the center and the shaft is here. So the green color one indicates the brush here. This indicates the brushed DC motor. Now let's discuss particularly about it. Brushed DC motors generate torque from a DC power supply by using internal mechanism called commutation. Commutation means 1-2 positions are there. One position will be up, down, 2 position will be down. So alternatively 2 position comes down, up, and 1 position will be down. So in that way this combination is called as commutations here. Stationary permanent magnets form the stator field here, which is surrounded, and the torque is produced by the principle that the current carrying conductor placed within an external magnetic field experiences a force called Lorentz force. You might have studied this in EMF. In a motor, the magnitude of Lorentz force will be output of the torque, isn't it, which is the function of rotatory angle. That this diagram shows brushless DC motor. So brushless DC motor, you can say it will be lightweight, but no brushes are there. Typically uses one or more permanent magnets in the rotor, and electromagnetic field makes the housing to rotate. So here this picture depicts how the stator and magnet fixed magnets are there. Motor controller converts DC to AC. This design mechanically simpler than that of brushed motors because it eliminates the complications of transferring power from outside motor to the spinning rotor. The motor controller can be sensed by the rotor via Hall effect sensors. The advantages of brushless motors are it includes long lifespan, light in weight, no maintenance required, high efficiency. Disadvantages, its initial cost is very high because small size it can be used in drones and all, small electronic components and all. Some brushless motors are sometimes called as synchronous motors also. So with this I wish to wind up the topic and learn properly. Thank you, students. Bye.